Alright, it's time for the solutions for the matrix inverses assignment. On these first four, all you have to do is figure out whether or not the inverse exists, and the way you do that is you get the determinant of the matrix. So take those and multiply together, and then take those and multiply together, and subtract the result. So those two minus those two multiplied together, so negative 4 times negative 3, minus negative 3 times negative 4. Well, negative 4 times negative 3 is positive 12 for both of these. That gives you 0, so this one has no inverse. If your determinant is 0, the matrix has no inverse. And moving on to 2, multiply, multiply, and then subtract. So you got 2 times negative 4 minus negative 8 times 1. 2 times negative 4 is negative 8. Negative 8 times 1 is negative 8. Negative 8 minus negative 8 is 0, because subtracting a negative, same thing as adding a positive. So number 2 has no inverse. Moving on to the next one. Multiply across the main diagonal, that's negative 5 times 0. When you subtract the other product of the diagonal there, 0 times 5, we get 0 minus 0, which is just 0, so this one also has no inverse. And then on to number 4, take our main diagonal, multiply, that'll give us 81. Subtract the other diagonal, 12 times 6 is 72. If you do that subtraction, it gives you 9. That's not 0, so this one does have an inverse. Has an inverse. Ta-da! There you go. So there's your first 4. Moving on to the next ones. You need to find the inverse of the matrix using the steps shown in class, which are row operations. So in order to do that, you're going to take your original matrix and you're going to add on the identity matrix on the end to make an augmented matrix. And then we have to do row operations to get these first 4 entries here to look like an identity matrix. These last ones will change, and whatever we get at the end is going to be our identity matrix for the original. So I notice here that 10 and 5 are multiples of each other. So if I were to take row 1 and subtract 2 times row 2, and leave row 2 the way it is, I would get, well, 10 minus 2 times 5. Well, 2 times 5 is just 10. 2 times 0 is 0, 0. And then 1 times the 2 would give me 2 there. So I'm just going to use this as my, that is 2 times row 2. So I'm going to take row 1 and subtract those. I'm going to get 0. 2 minus 0 is 2. 1 minus 0 is 1. 0 minus 2 is negative 2. And my second row was 5, 0, 0, 1. What I'm going to do now is I'm going to actually switch my rows. So I'm going to put row 2 up top and row 1 on bottom. And while I'm at it, I'm really close to having this be 1, like 1 and 0 and 0 and 1. I have to take this, though, and divide by 5, and this row and divide by 2. So I'm going to take my old row 1, divide by 2, my old row 2, divide by 5. As I switch the order, that's going to give me 1, 0, 0, 1/5. And then my other row, everything divided by 2, is going to give me 0, 1, 1/2, negative 1. And so now this here is the identity matrix, which makes this piece here the inverse. So the matrix I would want is 0, 1/5, 1/2, negative 1. That's the inverse right there. Let's move on to the next one. Again, add on the identity matrix here, and then do row operations to get this to look like this. And so if we do that, I'm just noticing here that, let's see, I want to get zeros and ones. So I want to get like ones in front, or I can get a 1 there in the middle. Actually, a fairly quick way to do this is to do is just take row 1 and subtract row 2. That would give me a 1 in that middle column. So I take row 1 minus row 2 and leave row 2 the way it is. I'll get negative 3 minus negative 5. That's going to be the same thing as negative 3 plus 5, so that's 2. 3 minus 2 gives me 1. 1 minus 0 is 1, and 0 minus 1 is negative 1. And my next one was just negative 5, 2, 0, 1. And that's okay. And I notice here, if I were to take twice row 1 and subtract that from row 2, this would be a 0. Because if I times that by, if I take this top 1 times by 2 and subtract it from that, it will make it 0. So I'm going to take row 1 and let it be that, but I'm going to take row 2 and subtract 2 times row 1. And real quick, 2 times row 1 will give me 4, 2, 2, negative 2. So I'm going to subtract these numbers up top from that row there, and it will give me 2, 1, 1, negative 1 as my first row, just how it was. I need to do 5 minus 4, negative 5 minus 4, that gives me negative 9. 2 minus 2 is 0. 0 minus 2 is negative 2. And then 1 minus negative 2 is the same thing as 1 plus 2, that's 3. So now I got this. Good thing I have a 0 now there, because what I can do, let's see, is I can actually take this entire second equation here and just take the second row and just divide everything by negative 9. That would give me 1 and 0 there. I'm going to take row 1 and just let it be that. 2, 1, 1, negative 1. And my second row is going to give me 1, 0. Negative 2 divided by negative 9 is positive 2/9. And then 3 divided by negative 9 gives me negative 1/3. So there's that. And now what I'd want to do is take row 1 and subtract off 2 times row 2, and that'll make that a 0 right there. And I'll leave row 2 the way it is. 2 times row 2 is 2, 0, 4/9, and negative 2/3. So I'm going to take row 1 and subtract all of those. That'll give me 0, 1. 1 minus 4/9 is 5/9. And negative 1 minus negative 2/3 is going to make it negative 1/3. And then on the bottom we have 0, 1, 0, 2/9, and negative 1/3. And that's actually really, really close to being answered. We just need to switch the order now to get row 2 up top, row 1 on bottom, just so we can have 1, 0, 0, 1, and then the rest of the numbers, 2/9, negative 1/3, 5/9, and negative 1/3. And so this final piece here on the right half is going to be my inverse, which is going to be 2/9, negative 1/3, and then 5/9, negative 1/3 as my ending matrix. Right there. Ta-da! Inverse. And that's going to be our first video.